In this video, we have discussed what consensus algorithms are and how they are connected to blockchain, but we haven't discussed what blockchain is actually, so you should know about that. Let's get started.
Consensus algorithms. This is Piyush Punia and Arif Ashar. Today we are going to discuss about consensus algorithms in blockchain. So let's first discuss why do we need consensus algorithms in blockchain. A blockchain is a decentralized peer-to-peer system with no central authority figure. While this creates a system that is devoid of corruption from a single source, it still creates a major problem, like how are any decisions made or how does anything get done. Think of a centralized organization. All the decisions are taken by the leader or a board of decision maker. This isn't possible in blockchain because a blockchain has no leader because it is a peer-to-peer system. For blockchain to make decision, they need to come to a consensus or an agreement using consensus mechanisms. So, how do these consensus mechanisms, or what are they algorithm? What are these algorithms exactly? What are some of the consensus mechanisms used in cryptography? We will talk all about this in next slides. In simple terms, consensus is a dynamic way of reaching agreement in a group. While voting just settles for a majority rule without any thought for the feelings and well-beings of the minority, a consensus, on the other hand, makes sure that an agreement is reached which would benefit the entire group as a whole. For a more idealistic point of view, consensus can be used by a group of people scattered around the world to create a more equal and fair society. The method by which consensus decision is achieved is called consensus mechanism. Suppose we need to add data, or should I say block in blockchain, then consensus algorithms will be at work. Many type of these algorithms as shown here, but mainly we will discuss proof of work and proof of stake algorithms here. So question arises, what is proof of work algorithm? This algorithm is used to select the person who will add block to the blockchain, also called miners. The basic idea is to solve a complex mathematical puzzle and easily give out the solution and reward the person who solves that puzzle. We are going to discuss it in more detail in next slides. So when a transaction occurs and that transaction data or that block is needed to be added in the blockchain, then the blockchain generates a mathematical puzzle and present it to all the miners. Then miners start solving the puzzle and try to do it as fast as possible. Approximately to solve a puzzle, it takes around 10 minutes. Once the puzzle is solved, miners send the solved puzzle to the network server. The network server processes all the solutions and the one with the correct and the fastest answer adds the block to the blockchain and gets rewarded. The same process occurs again and again for adding new blocks. So what exactly happens when a block is about to be added in a chain? A hash function is generated according with the input output criteria of the puzzle for the block and start pointing to that block. Now each block is filled with hash of previous block so that each of the block in the blockchain is connected to each other through this function, hence forming a chain called blockchain. Now to change block, it requires a new block containing the same predecessors. It is almost impossible to regenerate all the successors and change their data. This protects blockchain from tampering. So let's talk about what are the advantages and disadvantages of proof of work algorithm. The main advantage is that DOS attacks are completely impossible in proof of work because solving a mathematical puzzle requires a lot of computational power and to attack through it needs more power, which is useless because the cost is too high. Main disadvantage of this algorithm is 51% attack. That is, if an organization or a person uh, owns a 51% of the blockchain, then it will control most of the mining power. which will affect the blockchain. So now let's discuss about other algorithms.
My name is Aribashar Shamoon and I am going to continue with the proof of stake consensus algorithm. So proof of stake. Proof of stake is another very popular consensus algorithm which tackles some of the problems of proof of work. Proof of work is a competitive approach to verifying transactions which naturally encourages people to look for ways to gain advantage, especially when monetary value is involved. It was first introduced by a user named Quantum Mechanic in 2011 on Bitcoin Talk forum, as you can see in the screenshot in the PPT. This is from the same forum. Later it was published in a paper by Sunny King and Scott Nadal with the title PP Coin Peer-to-Peer Cryptocurrency with Proof of Stake. Now coming to the proof of stake terminology and implementation. So in the paper, Scott Nadal and Sunny King, they introduced the concept of coinage. Coinage is defined as currency amount times holding period. For example, let's say if Bob received 10 coins from Alice and held it for like 90 days, then we say that Bob has accumulated about 900 coins days of coinage. That is 90 times 10. In proof of stake, validators are there. Like in proof of work, there are miners. In here, there are validators who get to approve or verify new blocks, which is called the process of adding the new blocks is called forging or minting, as opposed to mining, as in case of proof of work. Now coming to the implementation part. In coin stake transaction, which is used in proof of stake, users put their coinage on stake to become a validator. It's like a security deposit. The validators is chosen randomly among all the users who put some stake to become validator. But here the validator is chosen completely randomly, but the amount put at stake does play an important role in randomization. Now, why can the other user or we can trust the validators? Well, validators lose their stake and all the fees they earned over time if they approve or they are verified found to approve a fraudulent transaction. So as long as the stakes are higher than the sum of all transactions, we can trust that the validators will won't do any such thing because they will lose more money than they can gain. Now coming to the comparison between proof of stake and proof of work and how proof of stake is a improvement over proof of work. So as Piyush already explained, proof of work makes users compete against each other to find a solution to a complex mathematical puzzle. Any user who successfully finds the solution would then broadcast the block to the network for verification. And once the users verify the solution, the block containing the transaction are then added to the chain. In proof of work, the miner would be forced to perform roughly around 2 to the power 53 hash function computations on an average, which sums down to approx 10 minutes for each Bitcoin miner with a decent computational power. Thus, this is not only an increment in power consumption but also gives an advantage to people with better equipment and more computational power. So people with higher hash rates gets to mine the incoming blocks more frequently, and thus they keep on getting richer and keep on gaining the control over the network. And not only this, miners join hands with other miners and combine their hashing power and their computational equipments and distribute the mining rewards among them, which allows them to gain control over the network, which is again not very decentralized as we think or as we thought in the initial stage that it's going to be. But with proof of stake, the users, which is here referred as the validators, doesn't have to compete against each other, nor do they need any heavy computational power. So anyone with any decent equipment can generate nodes and be a part of the network, making it more decentralized. One of the major threat for proof of work is the 51% attack, but with proof of stake, it is very unlikely. In order to make a 51% attack, the attacker would need to control 51% of the network, which again requires minimum of 51% of the current market capital. And let's say if Bitcoin was based on proof of stake, then in case of Bitcoin, with the current value of the Bitcoins, it would add up to at least $421.85 billion, which is very unlikely that any individual or a group of individuals can afford that much capital. We can clearly see that proof of stake is an improvement over proof of work, but no doubt proof of stake also has some flaws because proof of stake is still in its infancy and less battle tested compared to proof of work. And in order to perform more efficiently, it needs a larger network, because larger is the network, more will the market capital and harder it will be the 51% attack. Now coming to some of the cryptocurrencies that uses proof of stake are Solana, Cardano, Algorand, and Binance Coin. And not only these, Ethereum is also planning to switch to proof of stake from proof of work by the end of 2022, because now that it has a network large enough to avoid the 51% tax. Thank you.